Hello everyone. So now we will be solving the problem D of the contest, that is 1709. Now it's a pretty interesting problem. Let's first read the problem statement. You are given two array integers a1, a2 to an and b1, b2 to bn. It is guaranteed that each integer from 1 to 2n appears exactly in one of the arrays. That means from element 1 to 2n you will have all these elements in array a1 and b1, means from 1 to, let's say, 3 is n, so 1 to 6 elements will be there in array a1 and b1, array b and array a. So what is the problem saying? You need to perform a certain number of operations, possibly 0, so that the both of the following conditions are satisfied. Now what are the conditions? For each I1 to n holds such that ai is smaller than ai plus 1. That is, a should be increasing, right? Because if ai plus 1 is greater than ai and it keeps on going till n, then that means every element should be in increasing order. And the second condition is b should also be increasing. Okay, makes sense. And for each ai should be smaller than bi. Okay, so during each operation you can perform exactly one of the following three actions. You can choose an index, right, I1 to n, and swap the values of ai and ai plus 1. That means you can swap adjacent elements, right? Let's say if array is a, this is a1 and this is a2, so you can swap these two, right? Similarly you can do for b, so you can swap b1 and bi plus 1, bi and bi plus 1, or you can swap the values of ai and bi. That means, let's say, a4 and b4, you can swap these according to your will, right? And you need to tell the number of operations required to do so. Okay, you do not need to minimize the number of operations, but the total number must not exceed 1709. Find any sequence of operation that satisfies both conditions, right? So if you see properly, the number n, the size of the arrays, is only 40. That means we can write a code. We don't need to exactly think of time constraints right now, because see, n is way too smaller, right? So you just need to focus on what should be done to solve this problem, right? And let's see let's understand little nicely. So let's say this was the test case, the last test case. I have already written it, so it does not take much time of yours. So let's say this was the array given to us, right? Now try to understand this. See, what I want from here is that the array a should be sorted, right? A sorted, and b should also be sorted, right? A and b both should be sorted, and a of I should be greater than, a of I should be smaller than b of I, right? A of I should be smaller than b of I. Now think of this. First condition which should come to your mind is, if ai is greater than bi, then simply swap it, right? Now let's say we have 5 and 2 here on the 0th index, right? So what should be done? This should be first swapped. So what are we doing? We are first applying third. See, what is the parenting of answer? Let's understand that as well. So they have given output should be k lines for each test case, right? First you need to print the number of operations, that is k, and if you want to swap the values of ai and ai plus 1, then you need to print I, two integers, I and 1 and I means the index which you want to swap, right? Similarly, if you want to swap bi and bi plus 1, output two integers, 2 means that represents array 2, and I is the index which you want to swap. And if you want to swap the values of ai and bi, you need to print 3 and I. 3 is, that means if you want to swap between a and b, and the index which you want to swap. Okay, so what I am saying is, first think of this. Why not swap these elements in the first place if it's wrong position? See, 5 shouldn't be this, if you had sorted this array or something you have done. But if 2 was over here now, think of this. 2 should be in this array, not in this one. At least for this position it should be there, not here, right? Okay, so what we will do, we will swap 2 with 5. I will give you proper explanation why we are doing this swap. Please hold a bit, right? So the next is 3 and 6. Is 3 smaller than 6? No. So let's 3 is smaller than 6. So let's continue on the next index. 4 and 1. Yeah, this is also a concerning one. So you will swap these. So we will apply the 3 on the first index. It becomes 2, 3, 4. Right? 2 goes to there. 2, 3, 4. And 5 comes here. 5, 6, 1. And 4 was also a wrong thing. So we applied 3 on the last and it became 2, 3, 1 and 5, 6, 4. Now what we are doing, now we want to swap the adjacent elements. So we will use bubble sorting. Now see, side by side when we did this now, we are pushing these in our answer, right? So answer dot pushback 3 is the type of operation we are trying to do, and which index is this. So on the first index you try to do 3 comma 1 and 3 comma 3 on the last one. So I guess this part was clear, right? What we are trying to do, right? And you can see the array which we got is this. Now if you sort these array in according to bubble sort, what does it become? See, the array is at the end, array becomes 1 2 3, right? 1 2 3, right? And the second array is 4 5 6, sorry, 4 5 6. I'll make you understand how this bubble sort also works, but in the end, because that's not the main problem, right? So if the array is sorted, now you can see if a, first of all let's take the first condition, right? Condition 1 was ai plus 1 should be greater than ai. Yes, it is true for this index, this is true for this index, so condition 1 is passed. bi should be greater than bi plus 1 should be greater than bi. Yes, this condition is also true. And a of I is greater than b of I. Check. Yes, this is true, this is also true, and this one is also true. So all three conditions are passed and we will get our answer as these, right? Now how, after this part, I guess this part was clear, right? The problem is a little bit longer. Try to get hold with it, right? So now understand this. We are applying bubble sort, right? I will not explain bubble sort right now. I will surely explain it in the end, but let's hold why this thing is working, right? Because if I have said this and if you think this will work, you should question why this is working, right? So think on this. If I had this test case, right? Now see, 8 is in the wrong position, right? So whenever we are checking if ai is greater than bi, simply swap, right? What does this do now? In the b array, what does it do? In the second array, the largest element will be placed. Irrespective of anything, second element will be placed, the largest element will be placed in the second array. That is 8 goes in the second array. And let's say by the question was the index were given very hardly, then the second largest element would come to array A, right? Okay, this will not create any problem. Now you will ask why. See, when you will sort this array now, because see, after sorting ai, all the first condition are always correct because you will sort the array, and bi sorting will also be done. Now the checking part is if ai is smaller than bi or not. So the last index will definitely have a 7 and a 8 because you have done the swapping. You have swapped 7 and 8, right? Now let's say you might ask, now what would happen if 6 was there in array A and 5 was here, right? So this will again get swapped and you will get, wait, let me write over here. So this will, 8 will come to this position after swapping, right? Why this thing is working, I'm trying to explain that, right? 7 will come to this position. Now let's say 5 and 6 were here. So after swapping, 5 will come over here and 6 will come over here, right? 3 and 4. So see, this will not have any problem. So 3 will stand over here, 4 will be here, and 1 and 2, this also does not have any problem. 1 is here and 2 is here. So you can clearly see how this thing magically sorted and made place, not magically sorted, AI made this sure that AI is always smaller than BI. Try to understand this. I'm not writing anything, I'm just trying to make you feel this, that if you check at every point now, the largest element will go to the end of the array, at the end in the second array, right? This is the second array, right? I have made some mistakes over here, don't take this. Okay, so what I'm trying to say is, let's say if you swap if you just simply traverse and check which the condition, if AI is smaller than bi, then you are simply swapping it, right? Now this will make sure you can check any test case, you can think of any test case, the largest element will be placed in the array B only, right? It might happen that the second largest can be in A or in B, but that won't matter, that won't change this condition for sure, right? You can have some test case, you can do a dry run as well. See, now let's say the test case were like 5 and 6 or 6 or 5, so you will see the third largest element. Even if the second largest element got placed in A and the largest element was in B, you don't have any issues, right? Now if you see, if the second largest element is placed, now the third largest element will be simply placed in the array B, means 6 will come over here. If you can take any test case, if you have doubt in this, now you can ask in the comments. I will surely make sure that you can see how this thing works, right? I will give you the replies in the comments of how this thing is actually working. See, the second or the third largest element will surely be placed in array B and making this condition always true, right? And this is the way that this operation helps us in solving, right? Now let's come to the bubble sort part. Now after these operations, we have made an array A and B and make sure that if we sort this array, if we sort A array and B array, then A of I will always be smaller than B of I, because we already took care of this thing earlier, right? Now let's go to the bubble sort, right? Now what happens in bubble sort? Let me explain in this operation 2 3 4, right? 2 3 1, sorry, right? So in the first pass, what happens is it checks if its adjacent elements. Is 2 smaller than 3? If it's true, then continue. If 3 is smaller than 1, no, this is false. So what we will do is we will swap this, right? And in the answer array, right, in answer vector, we will push 1 because it's the first array and the second index. See, second index was being swapped now, 3 was being swapped. So we pushed 1, 2 in our answer vector, right? Now the array we had was 2, 1, 3, right? Now the second pass goes. What does the second pass check? Again starting from 1, it checks is 2 greater than 1, is 2 smaller than 1? It says no, false. What happens? We push in our answer 1, 1. Why this 1 is here? This 1 indicates the type of operation which needs to be done and on which index. The first index was wrong. So what we did is we pushed in our answer. Then it checks for the condition. Is 2 greater than 2 smaller than 3, right? So is 2 smaller than 3? Yes, it's 2. So nothing happens. And again goes to the third pass. Now what happens in the third pass? In the third pass it checks 1. Now whatever array we have, 1, 2, 3, checks for 2. Is 2 smaller than 1? No. Is 3 smaller than 2? No. So if no element is being given false, then we simply break out of the bubble sort, this loop, right? And we have stored it in our answer. If you want, I am giving you an option. Just you can pause it and see if your bubble sort, if you have any doubt, you can read this part. Bubble sort algorithm works like this, right? And in the worst case, it will take O of n square time. So now let's see the code part, right? Let's try to understand what we have done. So this is the bubble sort part. I will explain it a little later because again I'm repeating, that's not the main part of the problem, right? Now what we are doing is we are taking two input array and BRR, ARR and BRR, right? Now what we are doing, we are creating a vector of pair of int comma int. Why int comma int pair? Because it stores the type of operation and the index, right? Okay, so from index I equal to 0 to I less than n, what we are trying to do, if array is greater than BRR of I, array of I is greater than BRR of I, simply swap them and in the answer put 3 and I plus 1. Now why I plus 1? Because it was clearly mentioned in the problem that you need to push elements from first index, or means I plus 1th index, means array indexing starts from 1, not 0. That is the reason we are pushing I plus 1. So the first part is clear, right? Now what we are trying to do, now understand this. Now we are creating a vector of pair of int comma int count 1 and calling the function solve. Now this solve function is nothing but the bubble sort part. Okay, and first we are doing for array. We are trying to sort array 1, right? How it's going, let's see. We are creating a vector of pair int answer in this solve function, and from 0 to n we are checking bool swap equal to false. See, if nothing, this is a way to reduce time complexity in bubble sort, right? If you have not swapped any element, that means your array is completely sorted and you can simply break out, right? For j equal to 0 to j less than n minus 1 minus I j plus plus, if array of j is greater than array of j plus 1, you will simply swap it, and you are pushing answer dot pushback type comma j plus 1. Now what is this type? So when we are solving for array, na, this is the first type of swap, right? It was mentioned, if you swap from array, first array, you will pass 1 as your answer. So we are passing this type in the function when we are calling, right? So type and j plus 1, and if we are doing a swap, we check mark swap as true, right? And if no swap has been done, simply break out of this loop, and we are returning this answer. Okay, now what is the significance of this answer? This answer was a vector, right? Now let's go. Simply we are again calling the count function, and count2 is the vector, we are storing it, right? And we are sorting the second array as well, right? And simply pushing all these in our answer. So we are doing answer dot pushback count1 की जितने भी elements थे ना, we are simply pushing them in the आंसर वेक्टर. सिंपली काउंट 2 का जो भी वेक्टर का आंसर रिटर्न हुआ मेरे पास, मैंने उसको भी आंसर में पुशबैक कर दिया, राइट? एंड सिंपली आंसर डॉट साइज को मैंने प्रिंट कर दिया, और जो भी वैल्यूज उसका फर्स्ट होगा और सेकंड होगा उसको प्रिंट कर दिया, राइट? लेट्स डिस्कस द टाइम कॉम्प्लेक्सिटी एज वेल. सो ऑन द फर्स्ट पार्ट what we are doing is, on the first one we are simply traversing on this whole loop, right? Let me clear it. Yes. So O of n, y of n, see, we are doing this swap, right? If array is greater, array of I is greater than BR of I, simply swapping. So this takes O of n, and then we are calling a bubble sort, right? This will at worst case take n square. So O of n plus n square, right? N square, right? So this was the ultimate time complexity of this problem, right? So I guess the under code part is also clear. I will give the code in the comments, right? So if you have any doubt regarding this problem, or if you want any other problems from this contest or any other contest or any problems, you can definitely ask in the comments. I will definitely try to help you out, and please like the video if you understood the problem and my approach. Thank you for watching.